Okay, so polynomial functions. There's a lot of different types of them, and they're called power functions. And I'm going to go over just the basic layout, I guess, some of the basic properties that some of them have. And starting with the one that you should be familiar with, and if you're not familiar with, then I don't know why you're even watching this. And that's y equals x, which is just a linear function. And y could be f of x equals x, f at x equals x, whatever you want to call it. But we're just going to stick with y equals x for simplicity. So this is a Cartesian plane, and we know that it would look something like this, extending to the left and extending to the right forever and ever and ever. So that is linear. That's the most basic one that we know. And then we're going to increase the exponent because this is to the exponent of, hold on, let me change the color. This is to the exponent of 1. We know that. So we're going to increase it another to y equals x to the power of 2, or y equals x squared, which we should know that it is a quadratic function. So a quadratic function obviously just looks like a parabola. Extends from the second quadrant to the first quadrant, and it continues on and on and on to infinity. So that's the quadratic. So then we're gonna increase the exponent once more to y equals x to the power of 3, and this one is called a cubic function. And you probably touched very briefly on it in grade 11 functions, and it looks sort of like that approximately. So it sort of has this a sort of similar properties to the quadratic function in the first quadrant, but it's like flipped upside down on the other half of the y-axis. So then we're going to increase it once more, as you could probably guess, to y equals x to the power of 4, and this is a quartic function. Quartic, like kind of like quarter. quarter. So a quartic function looks very similar to a quadratic, except since it's x to the power of 4, it shoots up much faster than a quadratic because it would multiply much faster. So it looks something like that. It looks almost like it's squashed just at the bottom. So that's a quartic function, and then we're going to increase it once more to y equals x to the power of 5, and this is called a quintic function. And we're going to draw our Cartesian plane, and it'll look once again very similar to a cubic function, but it'll shoot up a lot faster as it's multiplied, like to a much greater degree. So you can, just looking at these functions, disregarding the linear one because it's such a basic function. If we look at quadratic and keep increasing the degree of the function, we can notice some similarities, of course. So we can tell that the quadratic function looks very similar to the quartic function, and both of these have even numbered exponents. And these are actually called degrees. So the quadratic function would be a second degree function. So this would be second degree. And then, as you could probably guess, with the quartic function, this would be called a fourth degree function. And then we're going to continue with the other pattern that we see. The cubic function looks very similar to the quintic function. And the quintic function has an odd power of x, and same does the cubic. So if we were to continue going x to the power of 6, x to the power of 7, to the power of 8, to the power of 9, and so on and so forth, then we could say that the odd degree functions, which would be the cubic and the quintic ones, they would have very similar properties, and they'd look very, very similar to each other. So this one would be third degree, And so would the even degree functions, like the quadratic and the quartic. They'd look very similar to each other. And then this one would be in the 5th degree.